Welcome everyone. Thanks for coming to the Apex Meetup. Hope you didn't have too much trouble with the traffic or finding this place. So today's meetup is centered around Apache Geode and Apex and how they can be used together. So Ample has been leading this integration effort, and Ample has also sponsored this meetup today. So I want to thank them for the sponsorship. Also, this meetup is being streamed on a webinar, so we have folks joining remotely. We have 3 talks today, 3 speakers. Our first speaker is Nitin Lamba. He'll be talking about Apache Geode and Pivotal's leadership role in open sourcing it. The second one will be from Ashish Tirose, and he'll talk about integrating Apex and Geode and the in-memory computation, storage, and analysis. The third one will be from Suhas Gogate, and he'll be talking about an end-to-end ad tech ingestion pipeline application that ingests from Kafka and loads into Geode that was built on top of Apex and runs on Hadoop. So a couple of quick requests. If you have a question, please raise your hand, and one of us will bring the mic over. This is for the benefit of folks who are joined remotely. And second is after the talks, there's a feedback form, so please fill in the form, and you can basically enter information like the problems you're trying to solve, your use cases, anything else. And I promise your efforts will not go unappreciated. You'll get a t-shirt. So with that, I'll introduce Nitin. So Nitin is a co-founder of Ample and leads the product management. He has also led product development at Pivotal, and has held several key engineering and business roles in his career. And he's going to talk about Pivotal's effort on Apache Geode.
Thanks, Prabhat. Can everybody hear me okay? Okay, welcome. Good evening and probably good morning, or depending on who is watching the streaming. You must be wondering that just because we sponsored the session, am I authorized to talk about Pivotal and their strategy? I think the reason being, the guys from Pivotal had some emergency last minute, they couldn't show up. But I figured that since I product managed Gemfire while I was at Pivotal, and I'm still a Pivotal alumni, from a pedigree perspective, so I can at least talk about what the thinking was behind some of this. What you saw in the video, by the way, was Richard Lamb. He was the founder. You missed the early part of the video. But he was the co-founder for Gemstone. And Gemstone has really long lineage. Even before it was written in Java, it was actually written in Smalltalk. Very few people know. So the company actually has longer than 15 years history. So what they covered was literally the more recent, right? Call it post-2000 kind of history. So the ideas are kind of, comes from more mission critical. One of the other co-founders, like Jax, who has been there with the company as an architect for the longest time. He comes from telecom background himself in the 80s and 90s. So, similar, I would say, origins, right? As in mission critical comes first, and that's where you'd see. So today I'm going to talk about a few things. I'll change the sequence a bit. I'll talk a little bit about Pivotal's open source strategy, and then kind of get into the Apache Geode. How many of you actually know about Geode before you registered for the meetup? Very few, so it's good. I mean, I'm a product guy by design, so I can't talk too deep development, otherwise, I'll get short anyway. So it'll give you a good overview. Some of this content might be, very similar or familiar with what was presented last week. We had actually our first Geode summit last week, which was kind of an open forum for a lot of talks. So let's get rolling. So Pivotal, if you know, actually has a lot of open already. I mean, if you are familiar with RabbitMQ, Redis, Cloud Foundry, some of those are more visible open source initiatives that Pivotal has been running. I would say for several years. Spring is a big one. So anybody who is doing any Java development has at least come across Spring in some form. I mean, it's a love-hate relationship, I know, right? Scala guys don't get along with Spring and vice versa, so let's not get into that today. But at any rate, I mean, there is a lot of momentum behind Pivotal and open source in general. So what happened was that they were thinking, and they had a big data portfolio, right? And they were just scratching their head, because if you look at the new data revolution, a lot of changes have happened, And being open source is almost the starting point of a conversation. Otherwise, enterprises just dismiss you. I mean, they're kind of sick and tired of proprietary single vendor kind of setups. So in that sense, it was very obvious for Pivotal, okay, what's the next step? So what they did was in early part of 2015, they actually, in February timeframe, they made a huge announcement that's saying all of our data products are going open source. It's a matter of when, it's not an if anymore. And as part of that, across pretty much all the data, big data suite, which is a sum total of GPDB, Gemfire, Hadoop was kind of open source already, but all of those were kind of made saying, okay, we are going to go it and commit it. Some are Apache, some are getting there, but in general, you can basically look at the source code and download it, whatever you want to do with it. So those are the four timing-wise communities that were formed, right? Geode was the first one in May. The source code was released late April timeframe. And then came Hawk and Madlib in quick succession around Strata, and then immediately followed by Greenplum database, right? And Greenplum database, for people who don't know, was one of those 3 MPP databases. Like you have Vertica, Astrodata, and Greenplum, right? And then Vertica was acquired by HP, and then Astrodata by Teradata. So I think so. The question is like, what's up with Geode, right? So Pivotal is to Gemfire as Apache is to Geode, right? That's the best way of understanding it. And I think if you have ever seen any of these ads, right? So Gemfire was a gem, or for short, and then you sort of break open and get your gem. Geodes were sold. That's kind of the whole idea. Again, it could be a backronym or somebody trying to rationalize their decision for Geode. I don't know, but it is what it is. So whenever you look at Geode, it is the open source Apache version of what was Gemfire that was referred in the videos. That's an easy one. Moving on. So in a nutshell, it's a distributed memory-based data management system, and it's kind of designed for essentially data-oriented apps. So what you'll see is it started out to being an application cache. I mean, you saw high trading, high volume sort of requirements. And then it sort of grew out of it organically, right? It was made production grade, one things were fixed at a time, performance, scalability. Also, it is transactional in nature. So it's, in some ways it has tunable consistency. So you could use it as a purely transactional in-memory store as well. So if you were to sort of say, okay, is this distributed Redis? Yes. Is it memcached? Also yes. Is it something else like operational database? Can you run queries? Well, you can run queries, but not SQL. You can run object queries on it. So it's kind of a bunch of different things, right? It's like 6 blind men figuring out an elephant, right? But it really depends on how you utilize it. It's kind of a development kit that way. And obviously a very powerful distributed data processing as well as event-driven, and we'll sort of cover some of that later on. I mean, what you would expect in Apache projects typically is that, hey, it's somebody did something and it's been run by one company, and okay, you know what? It's contributed, it'll probably get to production grade in 3 years, and then it'll probably get to maturity in 5 years. This is kind of a slightly different approach, right? It's already run in production, or several use cases. These are some real 1,000 customers, right? I would say that it's incubating, but it's rock solid. And some of these use cases, just to give you a sense of timeline, right? Some of the early drivers were just around like, I just have a lot of data, or I just want to reduce my maintenance costs because my custom inbuilt systems are not scaling enough. And some of the elasticity needs, I want to be able to run it across 100 or whatever nodes like Richard was talking about. So financial services and US DoD were the earliest ones to sort of bite on it. And later on, when you started running into what I would call some of the real-time needs, low latency requirements started to show up. And then also people wanted some flexibility around where the data lives. Would it live in memory, or would it be persisted, or some combination thereof? And that's where some of the travel portals, some of the largest ones that were actually moved and been using this technology, on their websites, and even online gambling was one example. Then you got into something interesting, right? When you have multiple data centers, and then you need consistency for, let's say some very critical data across data centers and geographies. Think of those as, take a large travel site. Let's say they have 3 data centers or even banks. They have London office and Tokyo office. They don't want some inconsistencies across the data centers, right, for some critical data. And those kinds of use cases sort of pushed us to further and further into even wide area network related consistencies, right, replication and all the other things. And obviously, uptime was also a key requirement. So you can sort of start running it and almost forget about it. So 2016, like I mentioned, was kind of a turning point for this whole entire code base. It was contributed to open source. We've actually had our first milestone release in January. And then first Geode Summit was last week, Wednesday, right? You can probably find a lot of recordings and slides from that summit on SlideShare. Just look up for it. You'll be able to read up some interesting talks from real customers and what they have been using, banks and a few others. And also it's kind of for speed and scale, right? It's not just one or the other, it's actually both. So just to give you a sense that, you look at the symbol here is actually China Railways, 3 terabytes of data in memory, right? That's a lot of data in memory, across a fairly large cluster. And about 40,000 transactions per second. People throw in big million numbers. So if you actually do the math for a per day, it's actually already in a decent millions, right? So like 4.5 or 6 million, whatever you want to do. Similarly, GE, I think this is a blog post you can actually search for on the web, the GE Water. And they actually deployed Gemfire in again, 17 billion records in memory, right? So it can really handle really large data sets. And this is one from India Railways, about 120,000 concurrent users. Now, mind you, these are not, this might look small for a mobile app or something, but these are the number of users that are making transactions simultaneously, right? That's kind of this, think of that as a peak load, right? Some other names, these are the publicly announced ones. They're probably a long customer list where Pivotal hasn't declared, so I can't talk about it. Impacting a lot of people, right? So just a nice tidbit, if you just combine China and India population-wise, that's like impacting 36% of the world population, right? So kind of, if you're making your trips during the Chinese New Year or in holiday season in India, I mean, you're sort of, the fact that the tickets are available or the pricing shows consistent, Gemfire has probably a role to play in there, right? Just to give you a sense of it. So this is probably kind of a higher level technical slide, but at least to give you a sense, it's almost at a cluster level, it's like almost a third generation architecture, right? It's peer-to-peer. So in some of the earlier, I would say generations, you talk about a master node and a worker node, right? Or make the master highly available. You'd see that in HDFS as well. But this is truly a peer-to-peer network. So the locator, which is kind of our internal word for a directory service, is actually optional. So the locator goes down, the servers still know what the other server is doing. And they are able to resolve sort of network partitions, availability, and who is primary, who is secondary, all by themselves. So it's truly peer-to-peer. And then you can add servers. If you have a peak load coming up, you spawn 2 servers in, and they will know and discover each other and sort of scale it nicely. So it's a very nice properties that way. Like I said, it was a powerful development kit. So lots of interfaces, obviously Java and a REST interface. So if you want to have Python or even a direct, other language bindings. There are some other interfaces for adjacencies like Redis and Lucene and also Spark. Some of these are experimental, but sort of get the idea. So the top layer, this can act as a persistent store for a lot of these frameworks, computing or otherwise. It's a durable key value cache store, right? That's kind of another way of describing it. So what you have is that, again, trying to show you some different properties. So locator would know, this is not the data, but sort of have an information of what data resides where. And also sort of what's the state of the server. So it sort of keeps a kind of a manager role of health of the system. But then you can actually have different regions. We call them regions call it different key value maps. I'll cover that in detail in the next subsequent slides. And then you can actually, define whether they are replicated or partitioned or whether they persist or not. Several different options and buttons you can tune it for. And then towards the end, what you do is you actually persist it. Again, there are a few options, HDFS being one, and some of the other, like the classic local file storage, as well as an RDBMS kind of connectors, right? So think of this as a fairly flexible in-memory layer that can, depends on what you want to do with data, but if it's on and it's actually continue to run, right? It's fairly scalable that way. So one might ask, what makes it so go really fast? So it's like it tries to minimize copying, right? It doesn't do it unless absolutely necessary, and it's almost like transferring, in some ways, just the ownership of primary versus secondary without sending a lot of data across the wire. Minimizing contention points, reading versus writing, and some of that transactionality is also optimized. You can run user code in process where some of the functions can be pushed down, and you can sort of operate where the data resides rather than pull the data up to a client and process on it. And a bunch of other things, right? I'm not going to go too deep, but partitioning, parallelism, also the benchmarks. I was talking before the talk to another person of interest. I mean, we have tests that do unit level, distributed unit on a same machine, and across machines. As some of these tests, at least at Pivotal, used to run across days. I mean, it's just like that. I would say that eye for quality has been there since the beginning, and we're going to make sure any changes you make to the code doesn't break the existing, right, whatever suite. So it's been, like I said, it's been there for a long time, and trying to enforce that discipline, right, as we are even moving it to the open source community. So a few basic concepts here. Let me pause here. Any questions so far? Or so far so good? Pretty high level, hopefully. Talk about basic concepts. So you saw some of those, but let's dig deep on about what a cache and region and a member and some of these are. So think of cache as nothing but a way, it's kind of a unit in which you would store all the data on a particular, kind of unit of data management, right? And you can configure that through different options. You can have it statically configured through like an XML definition or any kind of descriptive language. Or you can programmatically change that through Spring or Java APIs, or even from a command line. You can sort of make those changes. And this is nothing but a collection of region. Now what you'll say, okay, now what is a region? So region is actually, think of that as a map on steroids. So think of the key value store we were talking about. That's like a key value store on steroids. Highly concurrent, distributed. You can have a virtual region that spans nodes, spans JVMs, and it'll actually ensure that it's consistent and data duplication and all that good stuff will stay in place. It's also observable. And what it means is that any changes you're making, so before you're making the change, during the change, after you make the change, all those points you have callbacks. So you can make any changes, you can do replications and say, okay, and the tunable consistency will be important, because I could say, okay, if my this data set is mission critical, I want write-through transactions. So I won't say commit until it's done. Whereas some of them is like, hey, my data volume is too much, I'll do a write behind, so it's eventual consistent. So some of those are just different ways that you can configure this, and it's all up to you, right? So it's tunable. So we kind of avoid the cap theorem, kind of, what should I say, the challenge or a problem, right? We say, okay, make this C actually tunable, right? And worry about the other two. Region types, there are different ones. You can have it local, you can have it replicated, like I said, across, like every member will actually have a copy of that data. So think of an application where you're making a train reservation. I'm sort of just using that for now since we have talked about it. Your seat availability and your pricing needs to be replicated data. But your users, if your users logging in from China mainland or from, I would say Asia or from Europe or from US, the users may or may not be replicated. You can partition them nicely and the system will scale well. Just an example, right? There is some data you would want consistency on, some data in which case you will make sure it's replicated and it's always consistent. And others you can sort of, I would say, partition it nicely. Redundancy, again, a lot of options, overflow. This is, by the way, the whole list of different options. So anytime you configure a region from the command line, you'll actually see, okay, tell me what type of the region it is. And I mean, this is all documented, you can sort of go and have a look at. So again, different uses of your data, so it gives that flexibility of how do you want the system to treat your data, right? And you can have different regions with different properties as such. So something about durability, right? So I think we talked about write-ahead log. It's also about consistent recovery. I'll actually show that, and compaction. But then the idea is that you can actually store data not just in memory, you can push it to disk, and then you have eviction policies, spillover policies, all that is all tunable. We don't have to rewrite custom code and for every type of a data requirement. Member is, again, think of that as a role. So a client is a member too, a server is a member. Any place where you can potentially store data is nothing but, and it's kind of connected to the system. And then it's also embeddable within application. Like I said, it's a role, right? So if you're writing a Spring application, you can actually have a member defined, as a client cache too, right? And then you can sort of interact with it and then pull data from the server as required. There's actually a good section in if you ever get to docs out of interest, where they talk about what different forms of, I would say, configurations of topologies that you can configure it to. And you can have it all the way from just a memcached kind of next to, like a Spring Hibernate or some other Tomcat server. Then you can have it in a client server fashion. You can have it client server within data centers or across data centers. So there are different ways of configuring this thing. Client cache. So this one is actually, think of this as if you need some data and then you need very frequent lookups of that data, you can actually create a local copy of the data within your client application. And that will be kept in sync with the server side. So that's kind of a very simple example for it. But you can also run queries on that data, and as well as the notification is also bidirectional, right? Remember I told you about all the notifications before, during, and after a commit? You can actually listen to those events, and as soon as the data changes from a server, let's say from a different process, the client would be notified, saying, okay, my cache is consistent now. So again, a lot of flexibility in how you deploy it. So let's talk about persistent, right? And this is probably the easiest illustration to understand. Let's say you have 3 servers in the grid, and think of these like treat of these as regions, or these are actually referring to buckets. So buckets is nothing but like a smaller, several buckets will form a region, and you can deploy buckets elsewhere. That's kind of a smaller unit internally, right? But then you can treat this for regions as well. Let's say you have this configuration and one of the server goes down, right? So what will happen is the data is already there, but it'll be responsibility-wise, you'll say, okay, you know what, server 1 is down. For anything primary now, contact server 3. Because server 1, I'm not able to communicate with it anymore. The health is down, right? So then you'll say, okay, what happens? What happens if everything goes down? Well, okay, that's always an eventuality. But by the way, this is the only one that has survived, well, not only, but one of the very few data services that has survived the famous or infamous Chaos Monkey from Netflix, right? So it has been tested that way. I think some of that would be eventually contributed in Geode. I'm not sure about the timeline, but I think there have been talks last week about it. But now, interestingly, let's say somebody might say, okay, what about if the first server comes up? So the first server, since it went down, is intelligent enough that you will fetch the missed operations on restart. So it will wait until the new servers with more recent data will come online. And then it's what's called propagation of delta data. So I've restored my state based on the last write-ahead log I wrote and kind of whatever journal entry, and then I restarted it, and then say, okay, what has happened? 2 hours have passed, and I'm sure I'm not the most recent data. So I'll wait in line, let the other server tell me what my lost state is in lost transactions, and then sort of send it back and restart it. I think I'm doing okay with time, right? About 20 minutes? Okay. This is about operation logs. This again, there is some intelligence around compaction. So what you see between the two, right? Let's say you're changing the value, it's a put operation of a key value pair. And then you create it and you're kind of building these logs. When it comes time to roll over logs, what you'll do is you'll only pick up the most recent transactions. So if I change the key or the value for the very first one, you will not go to include the old stale values, right? So that actually helps even making smaller logs, right? So this is a log compaction thing, right? That it actually works help. So functions, this is kind of my last concept here before we sort of open up more formally for questions. I think of those as like push down smaller stored procedures from a database parlance. You can sort of send those back to where the data lives. And it's kind of used for distributed concurrent processing. So this is like more like the MapReduce before it was formalized as MapReduce, right? It's kind of it's highly available. It's somewhat data oriented, and it's member oriented too. So you have options, right? I'll give you an example here. So let's say I actually do a small filter that I want on this particular region. I want to apply a filter which matches a particular key, right? It could be a regex or anything. So what it'll do is it'll actually go and send this execution saying that, okay, whoever has this region, tell me, what the values are. So it'll actually distribute. It won't even hit the server. So you can see on the top right there the data store partition actually doesn't match the key. It won't even process that request, right? So it's kind of intelligent, somewhat data aware, right, or where the functions need to be executed. So that's about it. I think you saw, you can go test drive the product, or not product, it's kind of a dev kit, like I said. It's kind of a decently growing community there. You can download the bits, play with the release directly, or actually it's a very simple process. It's pure Java, so between a git clone and a Gradle build, you should be up and running in literally, there's actually a section on Wiki which is like Geode in 5 minutes. I timed it myself, it took me 3.5. So if a product guy can do it in 3.5, I'm sure you can do it in much better time, right? And thank you. Questions?
So Nitin, hello?
Yeah.
There's a question from the webinar. How should I reference the cluster? Is there a recommendation on how I should balance my queries to the data cluster?
Good question. I think you have an option. Typically what we do is, depending, like I said, on the topologies, you will either have a client cache or a sort of a client that would be your entry point into the distributed system, and you would typically program a client to be that's where your application code will reside. And then the client actually typically sends requests, depending on the configuration again, either to a locator or directly to the server. And then when failure happens, they themselves talk to each other and point you to the right direction anyway. And you have an option of caching that information. So the next time the server 1 was on, you'll actually now go to server 2 directly. So from a interaction perspective, you'll typically have, in a classic application, you'll have a Geode client, which will be talking to the distributed system. Hey, there's a question in the back.
Hi, yeah, very nice talk, thank you. So the value, what is the type and what is the key also?
So think of that as Java objects, essentially. So whatever Java objects would support, it's essentially an object store, right? So key would be your normal. In fact, I've seen even keys to be more sophisticated, but it's essentially an object, right? You can have string, integer, or whatever, right? But you can have even complex objects on the value side. It'll just, you'll probably make the region go larger. I mean, that's kind of the only consideration, but you can have any tiny
Does
anything.
it support this polymer?
So,
like the edge-based polymer support?
yes, so Geo doesn't. But I think you have to wait for the later on talks to actually answer that question. It's a good one. Any questions?
Any questions?
Oh, I think there's one in the back right here.
You mentioned about one of the features you mentioned was it copies at the very last moment, doesn't copy immediately. Can you elaborate a bit more about it?
So now you're getting close to where the ice starts to get thin for me, right? But I'll try and answer that. I think what it does is that think of it such way. Unless your redundancy of the system, right, how you configure it, right, for your particular region, and unless you have a strong replication requirement, like if you configure it through like a WAN replication, you will try and avoid data movement. So in that case that I showed you, so let's say if I already have a data copy and I am a secondary, for instance. So for me to be a primary, I don't have to worry about data or sort of making consistent, I would say a lot of data movement. So in some ways, it's like trying to minimize, because network traffic, you sort of try and optimize for too much. But if you have configured if for replication you don't have a choice. It'll actually make copies, whatever copies you have actually asked us to make.
So it depends on the configuration.
Yeah, it kind of depends on the configuration. Yeah.
You talked about it's transactional. Does it support two-phase commit and all that? You talked about it's a transactional system. Does it support
Yeah.
two-phase commit,
Yes,
Java
it does.
APIs and all that?
Right.
Okay, yes.
There's actually a very interesting locking service too. I mean, again, to sort of avoid a lot of those conflicts. But then, yeah, and all those, for transactions, like I said, it's tunable. Whatever you want to do, chances are that it's already done, or we'll have examples to do it.
Thank you.
All right, I'm getting close to my end time, so thanks again. And with that,